Another driving force that we're going to look at is the formation of a weak or non-electrolyte. And this will most often be encountered when we're talking about neutralization reactions. And a neutralization reaction will occur between an acid and a base. Let's first consider when we react a strong acid and a strong base. Let's take HBr and react it with barium hydroxide. This will produce, if there is a driving force, we'll take my cationic species here and swap them. So we'd end up with water and barium bromide. Okay, and if we were to balance this, we would need 2 HBRs in order to balance the bromines and the hydrogens. And then we will need more hydrogen here. So I've got 2, 4, and just 2 here. So I would need 2. So now we have the complete molecular equation balanced up here. And the next step would be to identify driving forces. So water would be a liquid here, and barium bromide, according to our solubility, is soluble. So we'd have to say, okay, there's no solid, there's no gas, but water is a non-electrolyte. So we do have a driving force here. So this would be a plausible reaction. We would go forward with this and say, well, can I write a complete ionic equation for this? So we dissociate my soluble strong electrolytes, 2H plus 2Br minus plus Ba2 plus 2OH minus. And this would give me water. It is not an electrolyte, so we leave it together. And then we have barium bromide. And Br is going to have 2 for the same reason that OH had 2 here. We have 2 OHs per barium hydroxide, and we have 2 bromides per barium bromide. So this would be the complete ionic equation here. What's our third step? We have to identify spectators. So my spectators appear on both sides as a reactant and product. So barium and bromide are going to be eliminated as spectators. And when we remove those, we end up with what is known as the net ionic equation, where we have H plus reacting with OH minus to give water. And technically, we would write this with the smallest whole number ratios that we can, and so this would reduce one step farther to just be H plus reacting with OH minus to give water. And this is our net ionic equation that we would report. And again, this will be the case for any strong acid, strong base. My strong acids will dissociate, my strong bases will dissociate, and boils down to H plus with OH minus making water. Any strong acid, strong base reaction will result in this net ionic equation. So that makes it a lot easier for us if we can identify one of our 7 strong acids as a reactant and one of our strong bases, those group 1 and 2 metal hydroxides. We can easily come up with the net ionic equation without too much working through. Thanks for watching.